Good afternoon. In the radioactive decay problem, the subject matter is from the math-based syllabus, logarithmic laws and definitions, use of logarithms to solve equations involving indices, derivatives of exponential and logarithmic functions for base E, and applications of exponential and logarithmic functions and the derivative of exponential functions. In terms of the general objectives, this is a life-related familiar question. It's complex and non-routine because there isn't enough information inside of the problem to solve for the half-life of the substance using the simple radioactive decay formula. Initially, knowledge and procedures are required to recall formulas for radioactive decay and the rate of changing radioactive decay. The student is required to recall the rules for differentiating exponential functions. That happens down here. And they need to apply logarithmic rules to exponential functions to isolate and solve for unknown variables in algebraic equations. Students must solve simultaneous equations, and they must recall how to do this from year 10 math. The students must use a calculator to compute numerical solutions to the variables. In terms of modeling and problem solving, after identifying the context of the problem and applying the correct formulas to work toward the solution, the student must identify the known and unknown variables, which is done up here and in this table. The student must come up with a strategy for solving for one unknown in terms of another variable, which we do with the simultaneous equations and also with the half-life. The student must determine the validity of the solution by substituting variables into the equations for changing rate in the equation for calculating the half-life, and we also do this graphically. In terms of communication and justification, the student must correctly interpret the terminology in the original problem to know which formulas to use. The student must apply the correct symbols to represent exponential and logarithmic functions and derivatives. So here, the index, the derivatives, and logarithmic functions down here. And they must be able to communicate the logical sequence of connected concepts in their work toward a solution using the correct literacy and terminology. And that's particularly important in this part of the problem where we're solving for one variable and substituting it and solving for the next variable and substituting that and arriving at our solution. Justification of procedures and results is communicated using literacy and correct mathematical terminology. It's also performed algebraically with a calculator here and using Excel and GeoGebra. So, technology. In terms of the balance course, the students are given two rates of change at 2 points in time, and they are asked to solve for the half-life of this radioactive isotope. So this is the application portion of the balance course. They must recall the equation for radioactive decay and calculate its derivative, and they must be able to determine and distinguish between known and unknown variables and apply logarithmic rules so they can isolate terms and solve for the unknowns. In terms of technology, there's plenty of technology here used to arrive at numeric solutions and to validate those solutions graphically. So there's our numeric solutions and to validate them graphically here and here. Initiative, this problem requires insight and creativity because there's more than one equation is required to solve for the half-life. To arrive at the solution of the half-life, the student must be able to sequence steps and isolate and solve for unknown variables. Complexity. The solution to this problem required a recollection of formulas for radioactive decay, the changing rate of radioactive decay, knowledge of the rules for differentiating exponential functions, knowledge of the rules for calculating natural logarithms, and knowledge of how to use a scientific calculator to arrive at a numerical solution. Additional complexity comes from requiring more than one formula to solve for more than one unknown variable in the problem and doing this in the correct sequence. Now the connected set of concepts. I've produced a concept map here. The student map, first off, identifies this as a rate problem, and a rate is a derivative of a function. So they need to think in their mind, which sort of function do I need to use? I use a natural decay function using base e in the equation because it's occurring continuously in nature, this process of decay. Because we're using an exponential, we're going to have to use logarithmic laws to extract variables out of the index, out of the power, and put them in the algebraic equation so that we can solve for them. We are also going to have to use simultaneous equations because we have variables expressed in terms of other variables which we need to solve for. And I think that covers it all. So thank you for listening.